Hello, astronomers. Ms. Getz here. I am absent today, or maybe you were absent on Monday, and I wanted to get you caught up on a little bit about how these spectra that we studied last week are used by astronomers to understand things about objects in our solar system and beyond. So we know that astronomers use visual methods. They examine the pictures of objects and look at their shape and structure and what they might be made of. So that's apparent composition. That's one way that astronomers determine what an astronomical object might be. And the other way that they do this is that they take measurements of light. And so if you were here when we looked with the diffraction grating through our spectroscopes, you saw some spectra that are indicative of different elements that tell us what element they are. So in class, we saw the spectrum of hydrogen gas, and we saw this really bright red, sort of orange color, and sort of a greeny teal color, and a blue spot. This purple is usually not very visible to most people. It's a shade of violet that's hard to see. We also looked at the spectrum of helium gas and nitrogen gas, and as you can see, these spectra vary. They change depending on what element we're looking at. And so this is something that is really, really important for astronomers because we can look at the spectrum of different objects. So, for example, if we look at the spectrum of a star, we take the light from that star, shine it through a prism or a diffraction grating like the spectroscope we were using, we get a spread out rainbow of that star's light. And you notice that this one looks like more of a rainbow, and what we saw in class looked like more like individual lines and less of a smeary rainbow. And that's one of the kind of cool things about spectra. There are actually different types of spectra depending on what perspective you're taking. A really hot object will glow with a continuous spectrum where you see a full rainbow of light without any harsh lines. But if that bright object actually shines through some gas, so that star is shining through this nebula, we get these little lines in the star's rainbow continuous spectrum, and it's called an absorption spectrum. And those lines are the lines of light, the colors of light that are being absorbed by the gas in the nebula. So it's kind of like the gas of the nebula are taking away some of the colors from the star's rainbow spectrum. And if the nebula is hot enough and it's emitting its own light, we can look at the light the nebula emits. That's called an emission spectrum. And you notice that these missing lines actually match up over here with the emission lines from this particular example nebula. And so through these different methods, astronomers can look at objects like nebulae and stars and galaxies and identify what are the different elements that make up these objects. For example, here is the spectral lines of our sun, which, pretty cool, pretty important to us. And we can look at these spectral lines and notice that, well, the sun has a lot of spectral lines, but some of them actually match up perfectly with the absorption spectrum of the element hydrogen. So these are those lines of hydrogen light, and these are the lines of light that hydrogen takes away from a rainbow, a continuous spectrum. And so that tells us that our sun, it definitely has hydrogen in it. But you might notice that there's all these other lines of absorption. And that means that, not only does our sun have hydrogen in it, but it must have a lot of other elements too that are causing these different absorption lines. And so astronomers can use this on things like our sun and its spectrum. They also look at the spectra of even more distant objects like this planetary nebula. So this is a nebula, and we're looking at a little tiny slice of its light. And just by looking at the light of this and spreading it out into its spectra, you can see that the spectra actually, they spread out really, really far. So it's a really long line. But there's all these individual little lines in this spectra. And you can see that some of these lines are labeled with particular elements, and they're particular transitions for elements that allow astronomers to figure out what is this nebula made of? What is it composed of? What elements or molecules? And another bonus thing that we can learn from looking at these spectra is the velocity of an object, which is pretty handy. So this is a huge tool astronomers use. They look at spectra. In our class, the tool that we're primarily going to use are visual methods. So we're going to be using visual methods that when we look at an image, we can identify what type of astronomical object we think it is based on the shape and colors and structures that we might see within that image. So today in class, I'd like you to work on an assignment where you're going to practice visual object identification. And so I have a set of mysterious astronomical objects, and I would like you to work on crafting a claim evidence reasoning, a CER, about 5 of those objects. So I'd like you to look at them and think about what kind of astronomical object you think it might be, and then you're going to outline what you see that is making you think that. That's your evidence, those observations you make, and your reasoning. How does that connect to what you've learned about different astronomical objects? So I have a quick preview for you of our assignment, and then you can go ahead and spend the rest of your class time digging into it. So on the first page, I have a little example for you. This is actually our astronomy picture of the day from last week, which is kind of cool. 247, I think. And you don't need to know that, but it's just a kind of fun coincidence. What we have is a claim here. So I've got my example claim. I think this object is a globular cluster. And then my evidence and reasoning I have combined together. And that's because sometimes you might say some evidence and then connect to some reasoning, something you know about globular clusters or galaxies or comets. And you might go back and forth. But I say that I see many individual stars clumped together in a ball shape. So that's what I'm describing from the picture. I'm listing out those things that I see, and I'm noticing the number of objects. I'm noticing their shape, a little bit about the structure, and a little bit about the density too. So there's lots of things that you might observe that you might write down as evidence. And then I go on to state my reasoning about why these things that I see mean that I think this is a globular cluster. On the next page of your assignment, you will find this same thing that has some sentence frames that you can use, and this overview of claims, evidence, and reasoning that you might remember from your 9th grade science class. Up next, you'll find a whole lot of different astronomical objects. Some of the astronomical objects, I bet you'll recognize right away. Some of them are even labeled. Some of them will be a little bit more mysterious, a little bit more puzzling. And I would like you to pick any 5 of these astronomical objects to write a claim that you claim that this is a blah, and your evidence and reasoning on why you think that is that particular type of astronomical object. Feel free, and in fact do, use the notes that you have on page 3 of our different astronomical objects. And if you get stuck, I highly recommend using some of these sentence frames or looking at what are the different observations you might talk about in your evidence section. So that is your goal for class today. Up next, we're going to start learning about constellations, which I'm pretty excited to do when I get back to class on Thursday. Have a very nice Tuesday, astronomers. Bye-bye.